I'd like to give a quick reminder about negative signs. Whenever you have squares or cubes, you have to be very careful about the effect that they have on negative signs, whether they turn two negatives into a positive or whether the result is going to stay negative. For example, if we have something that looks like this, negative 1 in parentheses squared times negative 1 squared, and the squared is only applied to this 1 right here. So if I expand this out, here's what this looks like. This looks like negative 1 times negative 1. Okay, that's this part right here. Okay, this part corresponds to this part, and this other part is going to look like negative 1 times 1, where just the 1 is being squared. So you have to be very careful about your negative signs. You also have to be very careful about your parentheses. If I write this way, negative 1 times negative 1 times negative 1 times 1, this looks like a subtraction sign. If I want to do something like that, I need to put these in parentheses. So I'm going to put parentheses around this negative sign as well, so it's not confused with a subtraction sign. As soon as we start to introduce ambiguity, then we start to make mistakes, we start to miscommunicate, and we don't want that. So let's rewrite this for the sake of clarity. Negative 1 times negative 1 times negative 1 times 1. And this will give me a positive 1, positive here for emphasis, times a negative 1 times 1, that will be a negative 1. So my result should be a negative 1. Now if I'm doing this straight from the original problem, I have negative 1 squared times negative 1, where the 1 is squared. I see that I multiply this by itself and I get a positive 1, and I see that this negative is actually talking about the opposite of 1 squared. So I'm taking the opposite of whatever this number is right here. This number turns out to be a 1. The opposite of 1 is negative 1. And that should give me a negative 1 down there at the bottom. So here's where people start to get confused. They're used to just counting negative signs, and that's not a bad thing to do, but here this will get you in trouble. If you just count the negative signs, there are 1, 2 negative signs. Our result ends up being negative though, so I can't just straight up count the negative signs. I have to follow the order of operations and work from the outside, from the inside out. So just like any order of operations problem, I start with the innermost set of parentheses. Here's an example. It's not from the homework. So let's take 2 parentheses, negative, another set of parentheses, x to the 3rd power squared to the 3rd power times negative 2x to the 4th power. And let's raise all of that to the 10th power. Now I'm not just going to count the negative signs, because I could end up with the same kind of mistake up here. And I'm not just going to wing it either. I'm going to start with the innermost set of parentheses. The innermost set of parentheses is right here. We want to square this guy. Let me do just that part off to the side. So let me do negative x to the 3rd power, and I'm going to square that. If I square this, that's the same thing as negative x to the 3rd power times negative x to the 3rd power. 2 negatives make a positive. So one of the negatives will take it to the other side of the number line, and the other negative sign will take us back to the side of the number line that we started on. So I end up with x to the, and when I multiply things with the same base, my base here is x. My base is not negative x, my base is x in both cases. When I multiply two quantities that have the same base, I add their exponents. So 3 plus 3 is 6. So this should give me a positive, for emphasis, x to the 6th power. Let's try and do that without actually looking at the, without doing it longhand. So I'm just going to copy everything except for what I'm changing. I'm just changing this part. A negative times a negative is a positive, so I'm going to end up with something positive. X cubed, and if I raise x cubed to the 2nd power, I get x to the 6th power. I multiply the exponents. X to the 6th power, and then the square is gone, so I just end up with cube. This is times negative 2 x to the 4th power, and raise all that to the 10th power. This set of parentheses isn't really necessary. I can just erase those. Now, a lot of people, when they see a power like this, they just think, oh, okay, I'm raising this whole quantity to a power, so this must automatically become positive, and it's not the case here. Let me do this in a different color. If I have x to the 6th power, and I have a negative x to the 6th power, and I raise that to the 3rd power, I'm going to end up with a negative x to the 6th times a negative x to the 6th times another negative x to the 6th. Now if I count the negative signs 1, 2, and 3, I see that it should end up being negative. So bottom line here is, if I end up with, if I have a negative coefficient and I raise it to an odd power, I'm going to end up with a negative as my final result. If I raise it to an even power, it will end up being a positive. So this is an odd power. I have a negative right there. It should stay negative. Looks like I might have too many sets of parentheses. I should have only had 2 sets of parentheses on these. So this set of parentheses will no longer be necessary. I know that this ends up being a negative because this is an odd power. X to the 6th raised to the 3rd power, I multiply the exponents and I get x to the 18th power. And I still have times negative 2 x to the 4th power, and this is all raised to the 10th power. Now, this guy is done with. This guy, I should try and take this outside the parentheses. Now, when I do this, I want to be very, very careful. If there's a power right here, I can't just bring this to the outside. But I don't have a power there. These parentheses are not necessary. If I had parentheses here and I had parentheses here, I have to recognize when I'm allowed to just remove these, when it will not change the result. I'm just using the commutative property here, so I don't really need those parentheses. Since this is a negative, I'm going to keep this in parentheses so that way it's not visually confusing. I'm multiplying by a negative number here. I can use the commutative property to switch these two around. Oops, I forgot to the 10th power here, and 4th power, and negative 2, 10th power. Okay, I can add these exponents together. I keep this negative sign. This 18th power right here does not affect this negative sign. I'm going to end up with negative x to the 22nd times negative 2. Now, I could do a couple things here. The easiest thing to do would be to simplify this first. So I'm going to go in two different directions. First one will be in this purpley color. So I'm going to take negative 2 times this negative, and I get a positive 2 x to the 22nd power raised to the 10th power. And if I simplify this, I get 2 to the 10th power. Originally this was x to the 2 to the first power. If I multiply these powers, I get 2 to the 10th power. And I also get x to the 220th power. I'm going to leave it like this. This is going to be a huge number, but 2 to the 10th power I can plug into a calculator at any point. Now over here, I'm going to do this a different way. If I take negative x to the 22nd power, and I raise that to the 10th power, and I take this negative 2 to the 10th power, what I'm going to end up with is, I have to be very careful with my signs here, I'm going to end up with, this is like a negative 1. Or I could just figure that this is an even power, so if I raise that to the 10th power, if I raise this negative quantity to the 10th power, I'm going to end up with the positive version of that quantity, and I end up with x to the 222nd or 220th, and that's going to be positive. And then this guy will also be positive because I'm raising it to an even power. So I'm going to multiply that by 2 to the 10th power. So this is, again, 2 to the 10th power times x to the 220th power.